Hello there. Today we're going to review the basics behind a very important concept, prime factoring. Let's get started. So, here is a good list of items that you will probably need. Your calculator needs to be scientific and capable of relatively advanced calculations. So in this case, I would be talking about having a fraction button and a square root button at the minimum. Also, line paper, always a good idea to take notes. And finally, you should have a camera on hand or a phone. If you ever need to take a picture of your work for whatever reason, it's always good to have one handy. Now, there's two things I want to sort of break down here. Prime numbers and prime factorization. So prime factorization is involved in breaking up, let me get my laser pointer here, in breaking up a number into its component prime factors, right? So first of all, what is a prime number? Well, a prime number is a number that's only divisible by 1 and the number itself. So for example, I have here 2, 3, 5, and 7. They're all prime numbers. They're only divisible by 1 and themselves. And a prime factor is basically a series of prime numbers put together, just like you see in green over here and as well over here, that when put together multiply to create the number that we're interested in. So in this case, 2 times 2 times 3 times 3 would all multiply to give you 36. And you can check that with your beautiful scientific calculator here and just do 2 times 2 times 3 times 3, and you should get a value of 36. Same idea here. 2 times 2 times 2 times 5 times 13. Once you go ahead and do all of that, you should get a value of 520. So the big question is, how do we get these green numbers here? Well, there is a specific procedure we'd like you to follow, and let me show you what that is. So here is the prime factorization procedure, and as I take you to the procedure on the left-hand side, on the right-hand side, you'll see me work through an actual example. In this case, we're dealing with 44,100. So let's go ahead and do this. Now, the first step is to write the number on the page with what we call an inverted division sign. So let's go ahead and do that. So here we have 44,100, and here is my inverted division sign. You can see how it has this L character right over here, right? The second step is to use, once again, your calculator to find the smallest prime number that's divisible by this number. So in this case, we have 44,100 again. And you keep doing this repeatedly. You do this again and again and again until it becomes basically a decimal, right? And so in this case, the first prime number that's divisible by 44,100 is 2. So I have that in green there. And that is equal to 22,050. So again, as it says here, we repeat this process. So again, we can divide this by 2. And that gets us to 11,025. Now, if you divide by 2, you would get a decimal, because again, the divisibility test here, 5 is not even, so we can't do that. So we move on to the next smallest prime number, which in this case would be a value of 3. So I have that written there. We go ahead and divide, and we reach a number of 3675. Now, I want to stop here and point out something really cool. We started with this gigantic number of 44,100. And now we're at 3675. So it's amazing how small this number has gotten just in the first little bit. Let's keep going. So again, if we divide this and we break this up into 3 again, we get a value of 1225. And now, as it says on step 3, we move on to the next smallest prime number. So I already talked about that. If you actually take your calculator and try doing 1225 divide by 3, again, you get a decimal. In this case, I have here 408.33333. That just gets repeated over and over again. So we can't have that, right? So in this case, we need to do 1225 divided by 5. So this is showing you an isolated example of when we need to basically switch to the next prime number. You go ahead and do this, and as fourth, the next prime number is 5. Easy check, the 5 at the end indicates that this is divisible by 5. So there's the 5. And then we get a value of 245 here. And again, of course, you can do 5 again. You keep doing this repeatedly until you can't anymore. So if you have the 5 there, you divide it by 5, you get a value of 49. 49 is of course 7 squared, and we're even more lucky because 7 is also a prime number. You divide that by 7, you get 7. You divide this by another 7, and you get a 1 at the end. Now, all of these numbers on the left-hand side in the bracket there, they are all what we call our prime factors. And now the last step is to write this in what we call exponential form. So what is this exponential form? Basically, it's where you write this in terms of how many of each thing there are. So as you can see, there's 2 2's right here. So we write 2 squared. And this question is set up so that each of these are squared. So there's 2 of these 3's, so it's also 3 squared, or 3 to the power of 2. 5, so we have 5 squared, and 7, so we have 7 squared. So this here is an exponential form, and as I've explained to you, these 2's here just represent the number of. So if there's 2 2's, you put a 2 with the 2. If there were 3 of these, if there were 3 3's, we would put 3 to the power of 3 here instead of 3 squared. So that's what this exponential form is doing. All right, so now I have 2 examples of prime factorization. What I will do is I will leave you with going ahead and doing this for 5 minutes. So definitely now is a good time to pause the video and to take this 5 minutes out and try prime factoring 72 and 196. Okay? So I'm going to skip this. So here are our answers. Hopefully you've had the chance to pause the video and try this for yourself. 72 is 2 cubed times 3 squared, and there you go. So then there you go. So again, you're divide by 2, divide by 2, divide by 2, and then you would switch over to 3 over here, as 9 is not divisible by 2. So there you go. 196 is very similar, except once you get to a value of 49, again, you can recognize that it's 7 squared, and bada beam, bada boom, bada bang, it's 2 squared times 7 squared. Okay, this slide is actually just some common tips with regards to prime factorization. So tip number 1, know the first few prime numbers and be comfortable using them more than once. So don't fear large exponents, just keep dividing by the lowest prime number as many times as you can before moving on to the next one, right? Tip number 2 is about 2 small prime numbers that are commonly used, which are 7 and 13. They're both very small, and they're both very unique because none of them have convenient divisibility tests. So they come up very commonly in many prime factorization questions. So we have here a 7 and a 13. Basically, if nothing else is working, try 7, it might work, and try 13, it also might work. This is just a really good 2 numbers to keep in mind because it's not easy to just check on a glance whether something is divisible by 7 or divisible by 13. The third tip is that anytime we have a terminating 0, every 0 contains 1, 2, and 1, 5. So you can actually use this as a cool prime factorization shortcut. So here's my example using 500. 500 has 2 of these zeros at the end. And each 0 is 1, 2, and 1, 5. So 2 zeros gives you 2 2's and 2 5's. Right? So we know those are divisible. You can do 500 divide by 2, divide by 2, divide by 5, divide by 5, in which case you're actually left with another 5. So I already have 2 2's and 2 5's taken up by my original prime factorization, and now I have another 5 after dividing out divide by 2, divide by 2, divide by 5, divide by 5, which means my final prime factorization is going to include all the 2's and all the 5's. So 2 times 2 times 5 times 5 times another 5, because that last 5 represents the 5 that's left over right here. Okay, so that is that. A bonus tip, a common number that likes to come up a lot is 1001, which is 7 times 11 times 13, right? So just keep that in the back of your mind. Okay, so here I have the king of all questions, which is 420, 420. And what I would like you to do is calculate the final answer, and please put it in exponential form for me. Go ahead and do this on some lined paper, and make sure you keep in mind all of these beautiful tips we talked about, okay? So now is another great time to pause the video. Go ahead. Good luck. Okay, let's take this up. So again, the first thing we do is you divide by 2, and you get all the way to 105, 105. Can't divide by 2 anymore, so you divide by 3. You get 35, 035. You can't divide by 3 anymore, so you divide by 5. You get 7007. If you divide by 7, you get to 1001. And now you can use that the bonus tip from the previous slide, which tells you it's 7 times 11 times 13, and you put it all together in beautiful exponential form. 2 squared times 3 times 5 times 7 squared times 11 times 13. Okay? So now you go ahead and you pump this into your calculator. 2 squared times 3 times 5 times 7 squared times 11 times 13. And you should end up with 420, 420. Now, there's many ways to do these questions. The important thing is that at the end of the day, you have the same prime factor values, even if you use a different way to get to them. Okay? All right, hopefully that made sense. Have a fantastic week. If you still need help, the first thing I would do is look through the notes that you've made on these lecture slides and do as many of the questions, the practice questions, as you can, because in math, practice makes perfect. All right, take care.